Hi, welcome to LayerOne 2012. How many of you is this your first LayerOne? Wow,
Whoa!
That's awesome. How many of you is this your first security conference ever? Okay, that's good. It'll ease you in so that when you go to DEF CON you won't feel so degraded and used. But welcome. We hope you enjoy this weekend. A lot of people put a lot of work into it, such as this fine man, John Norman / Arclight, and he's going to be talking to you about open source physical security. Before we begin, for those of you wondering, your parking is validated. We have a machine somewhere. Ask at registration.
You actually put your ATM card in it. Legit.
And so that's covered. We have in the first room next to us, there's hardware hacking as well as a number of vendors. After that's obviously registration and food and beverage. And then after that is the Tamper Evident Contest and Lockpicking Village. For those of you who are asking, are there any spots left on Tamper Evident? After this talk, which will be 11:30, if there's still boxes left, it's open to whoever wants to pick them up. So if you're still looking to compete in the contest, after this talk, come see me. And we'll see what we can do. And if there's a number of you, I would suggest forming a team because it's a lot of work for one person. You ready?
Just about.
Anyways, John Norman.
So, since you mentioned putting your card in things, this is my slide for It's Totally Legit. Speaking about, you might want to take this opportunity to turn off the Wi-Fi and Bluetooth on all of your devices for the rest of the con. I'm just saying, you know, it's not strictly necessary, but yeah, it is actually. As opposed to DEF CON where you just leave that in the car with the battery somewhere else. So my name is Arclight, or John, and I'm going to talk to you today about physical security. And we're talking about electronic devices, access control, alarms, that sort of thing. And my background, I'm not an alarm or security guy. I'm just a guy. We wanted to have an audited electronic access control system at our hackerspace, which some of y'all, hopefully all of you, will be at on Sunday, 23B shop. We're gonna have our after party there. So I guess we should start off with how many of you guys have interacted with one of these? If you used to, have a badge reader at work and all that kind of thing. You ever wondered what kind of goes on behind the scenes? Enough people mess with their keys and door locks and all the locksword stuff. So we found out this stuff is rather a black box. So what this is about, physical security, we're talking people, assets, equipment, buildings, electronic locks and access control systems, intrusion detection, and alarm technology. What this is mostly not about are mechanical locks. All of these systems do have that as I guess you could say an enabling technology. You do need to have a somewhat secure physical lock and strong doors and things like that if you expect these systems to perform. The network and information system security, that's also a foundation. Almost all of our alarms and access control stuff are eventually going to be talking over a network to a server or notifying people or whatever. So that's important, but also a totally different subject that is subject of other talks. Video surveillance. I recently went to, I believe it's the largest physical security convention at least in the US. It's called ISC West in Vegas. And what I found interesting was that it was basically all about cameras, and more cameras. Everyone seems to think that will solve all their problems. If we just have everybody watching everybody else, and maybe some cameras watching the cameras, and the people watching the cameras, that makes all of our security problems go away. While that is an important technology in the right use case and tied in with other things like access control and auditing and so forth, it's actually kind of a crummy deterrent according to a lot of studies, and it really only solves a limited part of the problem. And then security policy development. Ultimately, all this stuff is to support some kind of policy. If you don't have a sane policy, though, it doesn't really help. Okay, so why we're doing this? This technology, as I started doing some research about 2 years ago, trying to install something, I found out that these are pretty much all universally closed source and mostly proprietary technology. All the vendors basically will tell you that their stuff isn't vulnerable because nobody knows how to hack it, which we know from the computer security world that works, right? it's made of magic, as long as no one finds out what the magic is, it's safe. And yeah, okay, but the magic always gets out, right? So really, it's kind of hard to find out what's going on under the covers. And I did, doing enough research and diving in, discovered a few things like it's pretty hard to make a real risk-benefit analysis. You can at least decide whether you want to buy a better door lock that's harder to pick, or protect your asset some other way. But it's kind of hard to tell because all these things have wires and little black boxes, and they may or may not do anything right inside. So I'm going to take a quick trip through sort of security theory 101. Start off with what is security? In this context, we're not talking SQL injection. We're not talking about getting your credit card database pwned. We're talking about your actual stuff. So really, we have assets, and that could be everything from, it could be hard drives full of intellectual property. It could be people. It could be your facility. In our case, it's our hackerspace, and we want to keep the junkies that hang out in the alley outside of it, and us inside, generally on the other side of the perimeter, whenever possible. And most of our stuff, like, not at the pawn shop. So threats to those assets, you have different kinds of threat actors or people that, in this case, we're saying intentionally want to get at your assets in a way that's not authorized. And then, the type of countermeasures you can bring out. So when we talk countermeasures, right, what are those? Well, we're talking about things like the locks, the alarm system, the notification, the auditing, all that stuff. And all those things have, different aspects to them. You can increase security. You may very well, with the countermeasure you deploy, break something else. You might decrease security in some other area or safety. You could put a really awesome door lock on your front door, but if it takes a 4-step process to exit, you might die in a fire. So there are regulations and things around this, and the manufacturers of these have been working on this for a long time to make that, at least the physical part of it, work pretty well. But the electronic part, it's kind of hard to say. If I plug this thing into the internet to plug in, there's actually a cloud access control service. You put these little boxes on your doors, and then you connect to a cloud app. I'm not kidding, it's out there. Do they tell you anything about what what additional vulnerabilities you open up while adding these cool features? They really don't, right? So, what it comes down to, it's always a trade-off. Cost, right? This stuff can be very expensive to, really expensive. Convenience, that's actually a good thing. We typically talk about security or convenience, right? Having the, how many people have a really dreadful policy or password policy at their work? It has to be complicated, it has to be changed all the time. And so what do people do, right? They write it down, it's on a post-it note on the bottom of their laptop or something like that. One thing I found out with this type of technology, if it's done right, convenience and security can actually go hand in hand. Like if you make it convenient to lock up the door that goes out to the sketchy back alley every time, nobody props it open. If it closes on its own and beeps and locks, and people feel safer because they know when they're there alone, the default is that that's not happening, but they can easily walk in and out almost unimpeded, they actually will follow the security policy better. I think the biggest threat to, say, data center and other kinds of facilities like that in terms of security, smokers, right? Everybody has, almost every developed country has some kind of no smoking inside policy. So where does everyone go? They end up outside in the back with the door propped open. Well, this kind of stuff can, maybe they should have some sane policy, like a place to do that and not encourage you to do that, but you can do things like set up alarms and alerts if the door is propped for too long and stuff like that. So this is kind of an interesting thing. I actually found this in a physical security book called Electronic Access Control by a guy named Thomas L. Norman, and he's been doing this for a long time. But the 3 categories of people in your site, those who support the mission inherently, and those would be like the founders, homeowner, someone who has a vested interest, the partner in your business, and you, whatever it may be, relatively small group that maybe they aren't 100.0% trustworthy, but they're as close as you'll ever get to it because their interests are very much aligned with the interests of what's going on, the mission of your site. you have people who straight up oppose your mission, and those could be competitors, people who are just straight up thieves who want to steal your computers or break into your stuff or rob your employees, or if it's a store or whatever it may be. And then they're a fairly small group of people. And then you have everybody else, which would be those who sometimes support and sometimes oppose the mission. Those would be like employees, contractors, guests, visitors, and really all three of these groups have different needs. So core users, supporters of the mission, right? They have the same safety and security goals as everybody else that's authorized to be in your building. We want to protect them from perhaps outsider threats, perhaps from fire and theft and things like that to the extent we can. The people who are responsible for this obviously want to take care of their assets and their people, and then they are going to want to be able to manage this. So be able to tell who has keys to what, be able to revoke those or issue those, and have an idea. Some places also do things like visitor management, know who's in your building in case there's a fire, let's say, did everyone get out safely, stuff like that. Our criminals, outsider threats, that's pretty much what we always talk about when we're talking about IT security. That's pretty awesome. We have an outside, pretty clearly defined perimeter in the case of a building. A little different if you're a cloud application provider, it's where's your perimeter? But this is pretty obvious, right? You're either on property or not. And there are people who we just clearly don't want there, and we want to discourage them. We want to increase the risk associated with their, bad actor activities like stealing your stuff or threatening your employees. And then everybody else, right? So, that's mostly about managing inside threats, visitors, contractors, the pizza guy. I kind of like that. Every place that has, say, a PIN reader out front, apartment complex, even some pretty high security facilities I've been to, it seems like the pizza guy, or even worse, I went to a data center a while back that had a door hanger from the Thai restaurant guy. You need a handprint reader to get into that place. Those guys are ninjas, right? And people will think that pizza delivery is, critical enough to the mission that guy needs the code to get in. And so you want to be able to do things like find out, who let whom in, have access logs, maybe video, maybe be able to verify, what happened when. That's basically function auditing. It has some deterrence, but it's basically about finding out what happened after the fact. And then a really important thing is being able to issue and revoke keys and make those keys possibly have a finite life cycle. You issue a metal key, and it's basically there forever until you change the locks or you try and get the key back. How many people want to deal with getting keys back from hackers who moved out of state 2 years ago, right? It's not going to happen. And if you're running a for-profit business, that's 10x full, right? So what do you have here? We really perform 4 basic tasks with these kind of electronic security systems. For those outsider threats and to varying degrees the other inside players, we really want to deter, detect, delay, and respond. There's no such thing as perfect security. The manufacturer's literature for all this stuff, some of them will talk about everything end-to-end over every piece of copper is AES 128 encrypted. Well, it doesn't really, talk about some of the other things like, do they use the same key in every device that they send out? But also, they don't really give you a complete picture. The fact that you're going to put this perhaps even provably audited security device that passes some government or GSA or FIP standard on your drywall partition data center, maybe it's a waste of money. Maybe you should have spent some money hiring a contractor to build a solid wall and put a good door in before you spent all that money. So really, any number of people can break into stuff. All you're really going to be able to do is try and detect them, delay them, so that you can get a response from your staff, the police, whatever it may be. And we want to enforce a security policy at the end of the day by doing that. So I'm going to take you through, this is kind of an interesting model. This is in, have any of you guys read Ross Anderson's Security Engineering? Have you seen that book? I'll have links at the end of this, but I highly recommend that. It's a weighty tome. It's about 1,000 pages. The second edition is like your typical expensive tech book, but he did something really cool. He is a professor at, I think he's at Cambridge, and he put the first edition online as a free PDF download, and it's very good. It covers all kinds of things like database and network security, app security, and it covers physical security and even things like how nuclear weapons are secured. So he has a really interesting approach to all this stuff where they try and do threat modeling. They want to make this a little bit measured, a little bit more rigorous. And we're starting to do that. We're using mathematical models, much more security, and trying to prove all the test cases and does this or does this not sanitize the input data and so forth. Well, he has a whole chapter just trying to apply that to physical security. And so he comes up with these 4 model attackers, which I think came from some Army program years ago where they tried to figure this out. So the first one is Derek. Derek is a 19-year-old addict. He's looking for a low-risk opportunity to steal something he can sell for his next fix. That would be some of our neighbors at the shop. Charlie is a 40-year-old inadequate with 7 convictions for burglary. He spent 17 of the last 25 years in prison. Although not very intelligent, he is cunning and experienced. He has picked up a lot of lore during his spells inside. He steals from small shops and suburban houses, taking whatever he thinks he can sell to local fences. Bruno is not the Ali G Bruno, but Bruno is a gentleman criminal. His business is mostly stealing art. As a cover, he runs a small art gallery. He has a forged university degree in art history on the wall and conviction for robbery 18 years ago. After 2 years in jail, he changed his name and moved to a different part of the country. He has done occasional black bag jobs for intelligence agencies who know his past. He would like to get into computer crime, but the most he's done so far is stripping 100K worth of memory from chips from a university's PC back in the 90s when there was a memory shortage. And then we have our top shelf threat actor, Abdurrahman. Abdurrahman heads a cell of a dozen militants, mostly with military training. They have infantry weapons and explosives with PhD-grade technical support provided by a disreputable country's university. Abdurrahman himself came out 3rd of a class of 280 at the military academy of that country, but was not promoted because he's from the wrong ethnic group. He thinks of himself as a good man rather than a bad man, and unfortunately his mission is to steal plutonium. So, how do we deal with these? So your typical commercial business space, which, mind you, going through all the security catalogs, they talk about their good, better, best products. All of the products pretty much used in residential situations are all in the not good. Just basic things like the locks, the doors, etc. They're all the type that are not recommended for commercial applications just because they're not abuse resistant and they don't support some of the more secure stuff like some of the electrified hardware, putting the better high security lock cylinders in. You typically are going to have 5, 6, or 7 pin mortise lock, some tempered glass windows, and maybe a basic alarm system that people may or may not use consistently. I mean, how many people have had a job where they gave you an alarm code? Ever had to deal with that? And you come in and they scribbled some instructions that said, oh, it's so simple. After it starts beeping, hit star pound, star pound, command 7, your pin followed by star pound. Why do you keep setting it off? I think you're stupid, right? So what do you do, right? After the second time that happens, you just don't set it anymore unless the boss is around. Or you just make sure you're never the first one to come in or last one to leave because it sucks. So these things are maybe deployed 50% of the time properly, if that. That's probably on a good day. Larger sites may have their own on-site security staff, which vary definitely in grade, just like our attackers. We have everything from TSA to good security. Burn. Better locks. If nothing else, commercial sites are usually forced, large institutions are forced to buy quality hardware because the number of people opening, closing the doors, and banging on it, 8 to 12 to 24 hours a day is just, you can't buy cheap stuff, it'll just wear out. The better stuff tends to be more secure, and they tend to do things like pass the angry man test, where you can kick on it and hit it with your fists as long as you want, and nothing will really happen. You at least need 1 or 2 guys with decent tools and a little time to break into it. Whereas if you take the angry man test, there's the shining guy outside your apartment. I mean, how many residential doors and windows and so forth would survive that for more than seconds or maybe a minute, right? Versus, say, the door to a library or a school, you would hurt your hand, right? So it's one way of thinking about that. Really, your typical commercial space, the access control, or which is probably just provided by metal keys, the alarm system, so forth. That's targeted at your Derek and Charlie model attackers. Places like a properly run data center, high-value sites that handle money, valuables, equipment. They also attempt to delay a more sophisticated attacker like the Bruno guy. And he can do things perhaps like hire a cleaner to get into your staff, or reprogram your alarm by buying the identical alarm and program it to accept every key. Someone like that, if they really wanted your stuff, would probably get in, or they would do something like rent some demolition tools and cut through your wall. And all you can really do is delay that person and make it harder. Aside from the with or without tools kind of attack, all this stuff is rated by UL, and there's some ANSI standards for basically how long it'll resist someone with no tools, with tools, two people with different tools, so forth. None of these claim to have actual protection. They're only a delaying measure. And when our last attacker, really our top shelf threat, our guy who's stealing the plutonium, he's realistically a problem for the military. What you use to stop people like that would be mass. Mass stops things like explosives and small arms and chainsaws with carbide blades and things like that. And infantry, people with guns. You have really high security facilities. I think the best designed ones, in fact, are the ones that don't look like there's anything going on, like an embassy.
Or a sign in the window that says, "We have no plutonium."
That could work. Kind of like the no radio sign you put in your window in New York. But really, yeah, these kind of people, you ever look at something interesting? The Crown Jewels in England, they have this little low building, and they put you on a conveyor belt, and it's just regular like library cases with just glass. It looks like regular glass, although it's a little thicker. And it looks like nothing's going on, although if you were to heft one of the doors, you notice it's really well balanced, but like you tap it and it feels like it's made of something very, very solid. And then you notice there's an infantry garrison right next door, and there's planters and things around, but they're solid reinforced concrete with railroad posts and things in them. Those little subtle security features, they're big deployable barriers and all the entrances and exits and stuff that aren't obvious. And they're trying to to delay and inconvenience a top shelf attacker. And those other kinds of sites, they'll have a combination of visible and not visible measures. But really, all they're trying to do is delay that kind of person until in their case, the Marine detachment comes out with all their weapons and kills them. That's their idea. We're just trying to call the police, probably. So, typical features of one of these systems. There's normally a module, looks similar to this. This is my system, but it's kind of a loose collection of a bunch of different commercial systems and what have you. Typically controlled between 1 and 4 doors, almost never more than that. The cabling runs, unlike networking where 100 meters is no problem. You're running actual power to manipulate a physical device, so they can only go so far without having a power supply nearby. They may be controlled locally with some intelligence in the firmware. They may be like a small appliance, or they may report back to a client server app. There's typically, unfortunately, a Windows-only workstation that, if you're lucky, maybe some of the systems have a web app for managing it. You typically have some type of electric locks on the perimeter and or suite doors to your offices, things like that. And I'm going to go into those. You have some kind of access token readers. You see that okay, guys? You have things like cards. Those would be contact or contactless. They have their own different security issues. PIN readers, biometrics, other kinds of technologies. One of the key features is that you have to have some kind of exit device. Everywhere that is in the path between you and outside the building has to have an easy way for everyone inside the building to get out in case of an emergency. And that's fire, generally is the first thing people think of. But it could also be other things. If there's someone shooting up your place, one of the a few of the studies have shown that one of the best responses in many cases is to put distance and get away from those people. The lockdown idea isn't always a good thing. So typically exit paths, not necessarily coming back in, but exiting is generally something you don't want impeded for almost any reason. they say that a typical test is, can a person with no special knowledge get out, open this door and get out? So that includes things like panic bars, handles, doorknobs, stuff that people just inherently know how to use in almost every place that has buildings and walls. Sometimes a push-to-exit device. Motion detectors, we'll talk about those, but that's one of my favorite, especially when they're double glass doors and a motion sensor that unlocks them on the way out. One of the things these typically do, which maybe isn't obvious if you haven't been on the other side of building one of these systems, the push-to-exit device, the motion detector that lets you out, things like that, or sometimes the doorknob itself, typically send a signal to that access control panel to suppress the alarm that this door got opened. So they're basically saying this was a legitimate activity because somebody without a key was coming from the inside to out, which we allow. So don't alert security or set off the alarm. Now that's some ways a vulnerability, right? Because it's, can you trick it into doing that, when you're coming on the way in? Maybe. You typically also have some integration if it's a larger system where it can do things like trigger an event in the event log for your video system. The fancier systems, when someone comes or goes, it'll bring up on the screen, let's say the camera that shows the hallway of who just walked in, or if there's a visitor at the gate, that sort of thing. Typically do things like suppress the alarm system. A lot of them have integration. Those don't have to be even logical integration via code and APIs. They may just have like a dry contact from a relay. And maybe it goes to an input and the alarm system is wired to say, if you see this input, do this or don't do this, set off the alarm, don't set off the alarm. A common one with fire alarms is that if it's exit door, they want the local inspectors who control this, they call it the AHJ, the agency having jurisdiction, wherever you happen to be in the US, they may ask that your access control system open all of the doors to inside and outside access if there's a fire. So that definitely is a security issue. It's also an issue of safety, though, if they think that it would be a lot easier for the fire department to get in. So it's kind of a trade-off. That seems to make more sense if you have somebody on site who can watch the store while that happens. If it's a completely lights-out data center, I don't know. That may or may not be what you would desire. One of the other cool things the fancier systems can do is tie in with like building controls, like heating, ventilation. It can turn on the air conditioning in your floor or your office. For safety, it can do some cool things like light up, like if you badge in the parking lot, it can turn on a path of lights all the way from your car to your office. So it's a little safer and kind of discourages bad behavior. So this is probably going to be a little bit hard to see, but your typical system is going to have over on the left these distributed access panels. A door sensor, detect the position of the door, request to exit sensor, know when someone asked to be let out or pulled the handle and told the system essentially that they're leaving. Some type of access reader. These may be in different floors all over a building, all out in a campus. They will get back to some kind of panel that supervises them, where they typically will go to Ethernet at some point. They may be RS-45 in a local network. When it gets to a large campus, it's almost certainly going to be Ethernet tie-ins, at least back to after they get to the wiring closets, that kind of place. So here are a few things. These would be kind of rundown of the locking hardware. What is this stuff controlling? We talk about, at the end of the day, this is just a fancy device that accepts some signals and opens or closes a relay. So the electronics are a little bit hard to get right, but they aren't anything amazing that hasn't been done for like 30 years. So, they're controlling devices like, we just call it electrified hardware. Not electrified in the sense of shocking people, but electrified in the sense of there's some kind of electromagnetic device that, manipulates, pulls a pin out or unlocks a cam, something like that. So the first choice, if you have commercial doors or you can put one in, mortise locks. They're embedded inside basically a pocket that's machined out of the door, wood or metal doors. They have what's called a dead latch. It's not exactly a deadbolt like a Schlage deadbolt in your house. It's a solid slug of metal. A grade 1 mortise lock has to have at least a 3/4 inch dead latch. And you notice that little piece on top. Well, when those things close into the door pocket, there's a strike that they latch against. that little thing closes, and the good ones, you can't shim that. That locks it completely. So if you were to put a carpet knife or something in, if there was a gap, you didn't have an anti-shim plate or whatever, it wouldn't really be able to do much. The other kind, it's pretty common too, has actually like anywhere from like 2 to 5 individual dead latches that close in opposition to each other, so you can't shim it from either direction, and it's just as strong as a deadbolt. It has at least as much mass of material, just over a different configuration. And these are built this way so that when you hit the solenoid, these things either fail safe or fail secure. So either applying power to it opens it, or releasing power to it opens it. In case of fire exits, it's more common to be fail safe. These guys are basically going to become retractable. Either the act of turning the doorknob or the handle retracts those, or in a lot of cases, just the act of opening the door collapses those little dead latches. They capsize into the door pocket, and you can open the door. And they're made to latch on their own when it closes with very, very little friction. One of the key features, also the one on the right, the 1 1/8 commercial cylinder. Any kind of lock, if you have a choice, you'll have a lot of high security lock choices for the key bypass if you choose something that has that little threaded cylinder. There's also another one called SFIC, small format interchangeable core, I think, small form factor. Those are great too. When you get to the typical like cylinder, key and knob residential locks, those are hard to electrify, and you typically don't have a lot of good choices for security locks, and they're expensive. So the magnetic lock, how many of you guys interact with one of these on a daily basis, right? These are like love and hate. Locksmiths like installing them because you can put one on darn near anything. You can put it on a drug cabinet in a hospital, or you can put it on the front door to a lobby with glass doors that you can't drill holes or anything in. They have some serious downsides though. Now let me explain how these work. This metal part on top, that's maybe about an inch thick, and it's a big epoxy potted device filled with very fine magnet wire. It's a big electromagnet. And the part on the bottom, that's screwed to the door, that's called the armature. So when you close the door and apply power, that thing clamps down on it, provided there's a good fit up. And anywhere from 600 pounds to 1,200 pound models are available. They have 150 pound models for like little cabinets and things. They even have maybe 2,000 pound models. They're very strong if they're installed properly. They also are inherently fail safe. So if you cut power to it, it will open, which is a good thing. There's really no mechanical part to jam up because the door got messed up in an earthquake or whatever. It's just going to work. So those are used a lot for life safety things, even though they may not be as secure. A couple problems with them: they require very precise alignment. If there's so much as 2 sheets of paper gap between them, or like some clear tape, you can body check it and the door will just open with maybe 50 pounds or 20 pounds of force and not 2,000 or whatever it was rated to. And they do, the doors, wear and sag and things. They have to be adjusted from time to time. So the other problem, unlike let's say a mortise lock where there is a separate keyhole that can bypass it and a separate doorknob that you can turn to mechanically open it regardless of what the electronics say, these don't have that. You have to install a button, a request to exit sensor to interrupt power to it, sometimes both. Maybe a motion detector, request to exit, and some kind of button you push. So token readers. So we have a few different examples. These are from my collection. They typically have things like pin pads, RFID readers on board. This one in the middle is kind of cool. This is a Hirsch scramble pad. That's just a pin reader, but every time you hit start to put in a pin, it actually scrambles up the location of the numbers, and it has this interesting little thing with a bunch of sheets of plastic laid on edge that make it difficult to shoulder surf. You have to be looking at it straight on. One of the things, talking to people who admin these systems and so forth, they mentioned that people seem to be less likely to give up the entry code to the pizza guy when, one, it has a procedure you have to explain, and two, they look at that like, maybe they're trying to tell me that I shouldn't give that to anyone. So what these also have in common, some systems do have Ethernet directly going out with some kind of secure-ish protocol, but majority of these though are using either WIGAN, which is a 2-wire serial interface that sends everything in the clear, or RS-45, which is a long range serial port used a lot of industrial applications, typically up to 32 devices on there, but it's the big brother to RS-232 serial cables. Or they use some other type of proprietary protocol, like Hirsch has a proprietary protocol and a big angry message printed on the back saying it's a crime to reverse engineer this product. Kind of funny. A lot of other companies feel that way probably, but they don't. One of their security features is that our protocol is unpublished and only works with our stuff, so we can sell more of it. But in theory, that makes it more secure. That's I don't know. That's a little challenging. Because of that, almost all of these guys are going to be in their lowest security mode whenever they have to interact with another vendor's gear. So if you buy all gear from the same ecosystem, from the same vendor, they do have, in fact, an encrypted protocol, maybe even a public key exchange or a three-way handshake, so you can't plug in a rogue reader device, perhaps. But the second it has to interact with that fire alarm or that other building control system that's been there for 5 years, it's almost always going to one of these clear text, less fun modes, or it's going through a gateway that talks encrypted AES and on one side and dumb wagon signals on the other side. So definitely vulnerable to interception at those points. Some of the sensors we have out there, everyone has probably seen the PIR, the motion detector, right? They come in a couple different flavors. The good ones, like the one on the right, have both a sensor that detects, it's basically body heat, that's how they work. They have two sensors, a little Fresnel lens slices it up into zones, and when pretty much one of them goes hotter than the other zone, and they're sliced into lots of little pie slices, and they're scanned at something like a kilohertz, you'd have to move incredibly slowly to not trip it just by motion. You'd have to not be hot, basically. But they will go off. They also will go off occasionally for things like this one wall getting extra warm because the heating system's behind it, or the sun shines through the curtains right onto it, and quickly when it passes a tree. There's lots of reasons it can false. Microwave sensors can false for different reasons, like someone standing right outside your window knocking on the door can set it off, even though it's only supposed to protect your space. These dual sensor actually kind of have the best of both worlds. They won't go off unless the microwave and the infrared go off, and they reduce your false alarm by quite a bit. Acoustic sensors. The one on the right is a really old school ultrasonic motion detector. Those really aren't used much because they false alarm a lot and they have a limited range. They're basically a distance finder. So they're doing what they call volumetric detection. Is there something here closer than there was before? Acoustic glass break sensors, these are used quite a bit. They literally have a microphone and a little microcontroller or DSP chip and some filtering circuits that listen for the sound of broken glass. So when glass breaks, they will basically process the signal and they'll send out an alarm. They'll close a little relay. And those can actually even protect an area of several windows or a whole room if they're installed properly. And these all have directions for what they will and won't detect, and whether you need two of them or how you should wire them up. But those are actually kind of a cool sensor. When I mentioned alarm wiring, going through alarm systems and so forth, one of the things I discovered is that almost all of the commercial sites are probably not going to use wireless sensors. They don't want to have to send someone around to change batteries and things get knocked off the wall and whatever, and false, stuff like that. So they typically use what they call 3 or 4 state alarm supervision. And they basically have a couple of relays and they are a couple of resistors, and they form a normally closed loop. So what happens when your switch is closed on those sensors, current will flow through one resistor, through that sensor, and then back to ground or back to your 5 volt, simply like a 3 to 12 volt loop is common. All of these sensors have a dry contact, so you can in theory put whatever voltage you want through it. But basically, they're able to detect a couple different things. If that switch opens on that sensor, like someone opens the door or sets off the motion detector, that will change the current path, so they'll have to go through 2 resistors, and it can tell that. If someone were to short out the wires, the resistance would decrease, depending on where they shorted it out. And if someone were to cut the wires, it would go open circuit. All of those, depending on how they occur, can be detected as unique states, as a tamper, a cut, a fault, or an alarm, or an everything is A-OK state. So that's why I one of the challenges of designing one of these things, you want something that has some analog inputs and can differentiate these if you can. Makes it more secure. So talking about that threat model, now that we know what kind of the pieces are, what are some of the advantages? So it's easy to revoke keys. We can do things that are more difficult with mechanical locks, like we can allow flexibility in our security policy. We can say, hey, I don't trust this person, or they don't have a need to have 24-hour access to everything in here, but I would like them to have business hours access, or I'd like to restrict it to a certain time, a certain zone. I only want someone who has a meeting at this public meeting room, once a month, to just have it open and close for them once a month, and not 2 in the morning on Sunday. And I can do things like give my different access policies to my public areas. Maybe I can give my visitors the ability to come in and out of the outer perimeter into the lobby and the break room, but maybe not my R&D area. It will encourage people perhaps to follow a better security policy. Like doors can be always locked if it takes half a second to open them, and the badge is already around their neck. It's not as big a deal. We can alarm on things like human failures, door props, tailgating. There actually are sensors that are fairly easy to deploy that can detect how many people walk through a door, what direction they went through, the better ones. They basically use IR beams, and you just have a pulse counter that counts how many pulses came in and to the first one and how many pulses made to the second one. Interesting stuff. Of course, we can audit things, right? We can see the log if something goes missing, or someone had an issue after the fact, or an employee was terminated, or whatever it is. We can also integrate those other systems. So some of the disadvantages, we can definitely clone the tokens. Almost anything electronic can be reverse engineered and copied, right? You can do that with mechanical key too. One problem is that some of these can be done at a distance, which is a little different security model than we're used to. These all require electricity. Someone can deliberately interrupt or manipulate power. I had a customer, it's a construction company, and somebody sabotaged their generator so it wouldn't start, and then they cut a 4 kilovolt feed line using insulated tools because probably they made one of their electrical contractors mad. It happens, and it was on payday. So, you've got people who get an hour of overtime for every hour their check's late. Well, you do the math, right? So power is definitely something that you have to consider. Almost all these should have some kind of UPS. And systems can fail maybe in unpredictable ways. Mechanical stuff, it's pretty obvious it can either fail open or fail jammed up and you have to call a locksmith. Will these do something weird if they end up in a state where there's not enough power to reliably keep the microcontroller booted, or the lock draws too much power because you undersize the power supply and it reboots the thing? Those are all possibilities that need to be tested for. Brute force attacks, right? Has everyone heard of like what a set of tryout keys is? Those used to be car dealers had them, a key to like every possible Chevrolet. Well, nobody's probably going to do that in front of me, even on a modest lock. There's thousands of combinations. But if you can have a device, you can double-sided sticky tape to the reader that'll do that over the weekend while you're not there. You might consider doing that. You don't even have to be there. And of course, the network, the servers, the wiring, all of those things really need to be behind the fence, basically in the secure or more controlled area, and preferably not running around outside and not in conduit with, if possible, the boxes should have tamper switches, things like that. So some of the access tokens we have contact technologies. Those would be magstripe cards. Everyone has a bank card in your wallet, right? Just like that. There's a format called ABA. There are a bunch of proprietary weird ones used in hotels that are harder to read. I can show you the gear that does both those. Wagon cards, those are interesting. Those are a little card that has pieces of magnetized wire oriented north-south, and swiping it across a reader has little basically tape heads that read that. Those are fairly hard to clone. I mean, they don't contain very much data, and they're pretty old technology, but they're interesting because they don't have some of the vulnerabilities that like modern, usually contactless RFID systems have. There are also some neat things. There's smart cards like the Kinko's card. Strom Carlson did a talk about that. Those may or may not be. Those can be very secure, and they can also be pretty poor. The lowest level implementation just asks the card what it thinks its serial number is, or even worse, it just looks at a value that says is authorized or not, that kind of thing. Better systems, they can have kilobytes to megabytes of data storage, and they can do things like run an application that does a three-phase challenge response system. Hey, are you one of my cards? Well, I don't know. Are you one of the readers I'm supposed to talk to? And they negotiate a type of handshake where they do some challenge response and never actually trade anything secret to determine if they're supposed to get in. Those are better systems. It used to be the Dallas, now it's Maxim iButton. That's a little sealed metal can. It's used for environmental sensors. A lot of security guard systems use them. They have to clock in at buttons that are epoxy to the wall. But they have keychains and stuff. Those were kind of neat because they're very easy to hook up to an Arduino or some kind of electronic device. They have a simple protocol. And then the contactless, which is probably 90% of the market. People who run buildings like these, because there's nothing to get dirty. You can put the reader behind the glass even, so every bit of wiring is protected, which is good. They can be passive RFID, which is your typical thing you probably have in your wallet or your keychain. They can be active, like the mobile speed pass, asset tracking tags you put on pallets. Anyone ever use the toll road and seen that transponder you put on your dashboard? Well, that's an active RFID tag. Those have a long range. Long range often is not what you want. You know, you maybe want to not have this work until you are just about touching it. But on the other hand, if you're a warehouse, maybe you want your trucks to have the gate opened as they drive in, you know, and they're 8 feet off the ground and 10 feet from the gate. That's reasonable. And then they have things like car alarm remotes. They like putting these things in like residential home, you know, alarm systems and stuff. I'm not crazy about that. You're going to be building some of those for your badge, I guess. So the low frequency tags, these have a pretty short range on the order of like 0 to 5 centimeters. The power for it is actually being magnetically coupled, so they have to be pretty close to get that. I think it's the B field that does that. They're primarily read-only, like the HID 125 kilohertz tag everyone has on their wallet. There's an EM4100, which is kind of like an ANSI or an ISO standard that's similar to it, but open. There are read-write versions of that, like the Q2. I have some that work with this cloner that you can read a tag and then write a writable version of it. They typically have slow data transfer, and you're only pulling maybe between 32 and 128 bits of data off of them, and it's typically just like a fixed serial number. And some have security features like the high tag. Those are used a lot in automotive applications. So here's some tokens. I have a bunch up on the table for you to check out as well. They can be everything from an implantable glass capsule to your typical HID Corp key fob, your what's called a clamshell card that's has a coil of wire in it, and they're usually thick. You can tell they're low frequency tags. They're never paper thin. The high frequency tags, typically the 13.5 megahertz band, that's the most common one. A little longer read range, 10 to 20 centimeters. More advanced features possible. Some of them have little microprocessors embedded on them, and they can do simple encryption, different types of handshakes, stuff like that. They can, in theory, mutually authenticate, like we try and do with SSL poorly. Most of them do not support something like a full version of SSL or TLS. There's some kind of lightweight proprietary protocol and often a proprietary tag format and encryption that was made up by the vendor. The ISO 14443A is one of the most common formats, and that defines the low-level standards of that. The most common version of that is the MyFair card. That's a Philips semiconductor design, I believe. They're available in all kinds of different formats. These are used, the one on the lower left is an LA Transit System card. Turns out that is MyFair card. The one on the lower right, that's the hotel key from last year. Guess what? Marriott uses a 1K MyFair Classic, I think it is. So not the most secure in the world. It does have onboard encryption. You have basically small data blocks that you require, I think it's a 48-bit key to read and write them. Well, it turns out through talking to them and sending some malformed challenges and things, in about 15 minutes you can break all the cell security and you can read and write the code. So not terribly secure, but you have to understand these weren't necessarily designed for high security. They're designed for low cost, things like transit and bus systems and stuff like that. And they're being used more and more for higher value stuff that maybe they weren't engineered for. So some of the things you can use for auditing, this is a pretty cool device on the left. It's a card classifier from a company called RF Ideas, and they have two models, the high frequency and low frequency. And you can plug that into your laptop, and it shows up as a keyboard wedge. Basically shows up as another input device. You leave a card on it for about 10 seconds, and it will tell you what kind of card it is, and depending, it will try to read at least the serial number or whatever data it supports reading from it. If it's a more sophisticated, protocol that has to have a conversation with the card, it doesn't have support for that. But they do have models that you can hook up to a PC and configure to have those interactions. But this is kind of neat because you can take any random RFID tag and know pretty quickly what it is and get the serial number and a few things. This company sells some really awesome universal readers. They can basically be programmed to have up to one of I think one or two simultaneous personalities out of a choice of 70 different vendors' readers. So they can just emulate in software. And this device on the right I have over here, this is an EM card cloner. You can get one of these on eBay pretty cheap. This was I think $50. These are sold a lot because many of these tags are used in automotive applications. So there's a strong market for aftermarket electronic key tag cloners for cars. No one wants to pay $500 at their Mercedes dealer if they can they can go to some shop that will make them a working key for $50. So these are all over the place. Bottom line, right? Most of the security features in these cards are closed source, not well documented. You typically have to sign an NDA and be in their program to get any kind of detailed information, APIs. It really doesn't give you the warm fuzzies in terms of security. A lot of these have an active cloning community, mostly because of automotive users. And it was developed for low cost. Almost all the widely deployed systems like the MyFair that have been out in the wild long enough and subject to some rigorous evaluation have been found to be really lacking technically. So if it can be read, you should just assume it can be cloned. And you should implement your software on the back end with your software, your security policy, rather than the card. If you want to do something like increment a counter on the card, or just something basic like you swipe the card, it reads it, it rewrites it with a new key before it releases the door, you can basically not have to rely on a lot of that security if you want a better environment. What we also found out though is that most people don't care about that. Really, we're working on the Derek and Charlie level most of the time. Darn near anything we can do is probably better than the 5-pin leg lock we had on that door before. And our vulnerability is probably going to come from people misplacing their keys and propping the door open, or someone smashing the window, and not from someone breaking the theoretical encryption strength of our wiring, right? So we came up with some design criteria. We basically wanted this to be affordable. Typical commercial systems are in the order of $2,000 to $3,000 per door installed, and we didn't have that kind of money. So we want something that would use commodity stuff, which meant the Wagon interface. Those are the most common readers. You can buy new open-started ones. You can buy used building takeout HID and other readers on eBay. You can buy new ones for a couple $100. They aren't horribly expensive. We want to have a 2-door capability. And we want to be able to run independent of a PC. At least it could work in conjunction, but it should work if our server's down. And we want to have logging, auditing, and supervised alarm zones. And the other thing, everybody seemed to have a different idea of what they want their workflow to be. So other hackerspaces who've deployed these, they'll do all kinds of different things like time-based, have stuff open and close in response to when someone comes in the door. Maybe they want a door chime mode. Some of the stuff was available, commercial systems, some wasn't. And we basically want a board that could be, at least the bill of materials was under $100 if possible. And you want to use something people can maintain, like Arduino or some other open source micro. So now we've had these out. We've been selling them to other hacker spaces as well. And there's about 15 active sites, probably 300 or 400 users enrolled in it. And we have, I guess, about 4 code contributors. We've got a database app someone's developing. Someone's already done a simple web-based front end for it, has a serial console now. Linux scripting. Start off our 1.0 ugly version, went to the version 2, which is deployed at most of the sites. And now we have a version 3, which has a bunch of fancy stuff like support for an LCD. The Arduino's built in, or you can use your other, whatever favorite Atmel programming environment you want. It has 4 alarm zones. It has input protection. Really, these devices are mostly about protecting the inputs and outputs from voltage spikes, and you're turning big, heavy magnetic things on and off, and you need to suppress all of those transients and all that stuff. So the electronic design part isn't super complex, but it's got to be made at least as robust as stuff that goes in like a car. It's a bad environment. And some of the features we have now, RS-45 port, 2 reader support. We have a built-in Atmega and a USB chip. We found a nice little 128 kilobyte user interface, so we actually store all the tags on board. The old one we could put, I believe, it was 200 users on. This one, in theory, it could be expanded to 10,000 plus. People have also been wanting to use these and have been deploying these for locking out like their equipment. Maybe they have a laser cutter or a CNC machine. Well, you can wire one of these relays into the emergency stop button and make people badge in, and before they're able to activate the thing after they set their program up or whatever. And we put a real-time clock on board and a bunch of auxiliary I/O so people can use them. And we also came up with a mega version, which we're going to be selling pretty soon. And that has 8 relays and 15 alarm zones, and also a voltage monitoring thing. So if you have a UPS or some other system hooked up to it, it can tell if it's on battery and how healthy it is. And we kind of came up with an overall architecture where we're distributing these small modules, and they can be linked up with RS-45 and then go into master Ethernet system. We're looking at also, we've been using little called plug PCs. It's a small Linux computer, and we're looking at the Raspberry Pi. A couple of our users just got them, and they're working on integrating them. So it costs $30 to $50 to add Ethernet to any of the Arduino and small microcontroller devices if you're not doing it in quantity. Well, now there are basically full-blown servers available in the $30 price range. We're thinking of maybe just skipping that and going straight to a little server device on board. So this is your typical install. A lot of people have been putting these in just like old alarm system panels that came with their buildings, things like that. You've got a power supply, a battery backup, and then you just move your wiring in there. So really quickly, the wiring, you have to protect it. They're man-in-the-middle attacks. You can definitely have a replay device that will listen to a valid card read and replay it if you swipe your card that's the rogue one. Zach did that at 2007 LayerOne, I believe. The wiring can be shorted out. You can possibly blow some fuses, and if it's a fail open or fail safe door, you may very well open the front door. So subtle things like not wiring the reader to the same that's on the outside to the same power supply or fuse as the inside. And you can do things to subvert alarm sensors. And the readers themselves, they have outside wiring. It can be difficult to protect. You can clone, skim, do all kinds of stuff to them. You can do denial of service attack. A lot of these cards have no anti-collision capability. So if you were to just epoxy one of these little RFID beads to them, nobody's valid card would ever be read. So kind of not obvious. Maybe it's the electronic equivalent of sticking super glue in someone's lock. And very few of these systems are doing any type of encryption or challenge response. What we have been looking at is doing things like maybe having an interactive conversation with a phone app. Some of the newer Android phones support NFC, near field communication. That's basically, it can act like a MyFair card or reader. Kind of cool stuff. All of these door hardware devices have vulnerabilities. You can shim a piece of paper or something like that into the door magnets. Some of the strikes, you might be able to put a strong magnet on it. And this is my favorite. Double door with a motion detector and a magnet. All you have to do is wave a sheet of paper in between these and they open. And there's all kinds of variations, like putting a balloon underneath and doing things like that. The classic Bosch Rex sensor is almost always pointed down, and it's almost always seems like next to something with a gap in it. So anyway, we're about out of time, but looking to the future, we're thinking about things like having multiple unreliable sensors. Really, we want to reduce the falsing as opposed to increasing the alarms. So can we have different types of motion and other detectors that are using some of the algorithms that people are doing, like for robotics and self-driving cars, train it up, have some heuristics so that we run around with it in training mode for a week, and then we tell it, hey, 3 different sensors within 10 minutes have to trip to call the police, or 1 or 2 have to trip to tell that someone is occupying it. Maybe we can do some things with OpenCV and machine vision. Linux MCE is a great package. It's actually a whole Linux distro that can control lighting, Z-Wave, stuff like that. And maybe even go into things like the software-defined radio, detect jamming of our Wi-Fi or cell phones in the area and things like that. Maybe enhance our privacy, like maybe we don't want to videotape every area if people are in those private areas. We only want to tape them when the alarm is armed. So we could do things like that. So we have some books, recommended reading. Questions? Real quick, anybody have a question? All right, then I'm going to throw it. Okay, what do you got? Oh yeah, we have kits available. There is a website, there's a Google Code site, and I have kits available. But let me do this. Who has an RFID? Who's heard of the MyFair, the RFID cloning attacks? Anyone heard about that? Okay, does anyone know? Can anyone name another famous transit system that uses the MyFair? Boston, that's right. You get beef jerky. And who else said Boston? All right, you get a gun cleaning kit. Can you pass that back? And the last one, for a shake weight, okay? You're gonna bulk up that left side, get some symmetry there. All right, for a shake weight, does anyone know what voltage level is used in the Huygens readers? What's that?
3.3?
No, the voltage level.
Oh.
Anyone know that?
One side plus, one side 0, 5, 24 volt?
No, but the Hirsch scramble pad does use 24 volt. Everything else uses 5 volts. But you know what? I'm going to give you the shake weight for trying. Nobody else stepped out. Thank you, guys. I'll have a bunch of this crap here, and I'll have the presentation in PDF form shortly. You guys can play with it.